So let us start with the actual demo. The first part we're going to start is with the SandBlast network demo scenarios. The goal of it is to demonstrate in real time the capabilities of our SandBlast network solution, focusing on the threat emulation and threat extraction core technologies. Stage 0, this is the first stage. This is basically before we start talking about advanced threat prevention. We're going to demonstrate that today traditional antivirus solution or basic threat prevention is not sufficient anymore to stop what we call Gen 5 of attack, and traditional signature-based solutions are not really efficient against those types of sophisticated attack. So the way we do it, we go to the environment and we log into the attacker machine. Notice that in CloudShare, you have an RDP access, remote desktop access, and a console access. Use remote desktop whenever possible. You can use remote desktop for the entire demo. Remote desktop is a remote desktop over HTTPS. Sometimes you'll see, if there are cases where you see a login issue or it's tries to log in but you see it's being stuck, just refresh the browser. It will reconnect you with the remote desktop. If you need to reconnect to the machine, you just click reconnect here. There are additional keys here. This is the connection detail, what you see here for the entire machine, including the credentials. And if you want to revert the environment, you have the possibility to revert the entire environment, or from the machine list, you can revert a single machine like this. So in case you're running, let's say, the anti-ransomware scenario before the behavioral guard, and Bob PC in the anti-ransomware scenario gets encrypted, the behavioral guard scenario will not work on Bob PC. So if you want, you can revert just Bob PC from the machine list. You go to Bob PC, you click revert, and then Bob PC will get reverted. Since Bob PC is not protected and we're just showing on it, I'll explain soon, we're just showing the effects of what happened when you open or execute an unknown malware on an unprotected machine. So let's continue. The first scenario, as I explained before, the first scenario will be about showing that traditional antivirus signature, traditional signature-based solutions are not sufficient anymore. And from different research that was done from 2 years ago and current year and past year, we can see that the efficiency of those solutions is decreasing. What we can see is efficiency of less than 50% today. So the first thing we'll do is we'll use this script, first step variant, double click it, and you'll see that we have different files here. The first file that we're going to use is called resume.doc. We're going to type in resume.doc, click enter, write random C, doesn't matter, some letters and numbers, click enter. What you'll see here is that the hash changed. So we took, let's say, a known malware, and we changed the hash of that malware to a different hash. Now it's an unknown malware. For instance, if we open the Chrome browser here, we can browse to VirusTotal. VirusTotal is an engine, basically a portal that includes around 60 different antivirus engines that will be able to scan files or even URLs that's being uploaded. So we're gonna click choose file, and you can see that C malicious files is the folder that we're hosting resume.doc. We're gonna choose resume.doc, click open, and click scan it. So we've uploaded the file. You'll see that if you already know the file, so if VirusTotal already knows the file, it will show you the result immediately. In this case, this file is not known, it needs to be scanned. So what you'll see is you'll see that all those engines are now scanning our malware. Since it's unknown to any traditional signature, it will need to be scanned. And what you'll also see is that those virus, basically those engines will not be able to detect that resume.doc is a malicious file. So you can see it here. You can see the start of the result. If I go back to the guide, you'll see everything step by step. Everything is written as a step-by-step with screenshot. So what you should also do is follow the guide, make sure that you're performing all the steps correctly. There is an additional information here. Okay, So read the additional information, you'll be able to talk about the scenario and what we're doing. And this is just a screenshot of VirusTotal here that shows what will happen. And you can see that it starts scanning. You can see that currently 0 from 54. It will finish analyzing. It will get 0 from around 58 engines. So antivirus engines that scanned this file didn't detect it as malicious. There's a few things to say about resume.doc. Resume.doc is not an actual document. Since resume.doc is not an actual document, it's an evasion technique that we've used. So resume.doc is an archive. It's a .zip. We manually changed the .zip into .doc to try to evade different types of detections. Another point is that resume.doc is a password protected archive. We've used one of the most common passwords used today. And as you can see, different engines doesn't have the capabilities of inspecting a password protected archive. We're using a password protected archive not because we want to show how we handle password protected archives, but we want to explain that sometimes there isn't a way to inspect all the files in the network. That means that we'll try to inspect as much as possible. We'll show with threat emulation how we are able to open password protected archives, and we'll talk about the method. But we're using this type of sophisticated, you can call it sophisticated attack, to show that not every file can be inspected in the network. And this is very important because it leads to fail open, fail close situations. In fail open, fail close situation, the organization decide what to do in case the solution is not able to inspect, let's say, this file. So in fail open situation, you just let the file pass through. You're supporting the business continuity. You want users to keep working. So you're reducing the level of security in these situations. In fail close mode, you're blocking every file that you're not able to inspect. So the solution is not able to inspect the file. It will block it. It will create an additional overhead to IT and the operation because users will open tickets to receive files that are being blocked. On numerous occasions, it can be a timeout, can be an error, it can be a password protected archive, and so on. So in this case, an organization needs to decide how it will work. When we'll go to the SandBlast agent, we'll discuss about the SandBlast agent. When I have a SandBlast agent installed, I can move, if I'm working in fail close, I can move to fail open and let the endpoint do the inspection, because at the endpoint, the user will open the password protected archive or the password protected file, and the endpoint, the SandBlast agent, will be able to inspect it on the endpoint computer. And it will allow an organization to keep the same level of security, but to work in situations where it doesn't create an additional overhead to operations, to IT, but the security stays the same, and we move the inspection to the endpoint. When we talk about SandBlast agent, we're gonna discuss this. So this was the first step, and now we're gonna move to the first stage. Stage 1. The goal here of stage 1, as you can see here, is to demonstrate prevention. Okay, with threat emulation capabilities, we're going to demonstrate various capabilities of threat emulation. Threat emulation is a family of technologies. It is composed out of more than 30 sophisticated engines, and this is what you should talk about. So the first thing is you talk about threat emulation technologies, the solutions. You can talk about the different engines that we have, like the CPU level engine, like the push forward, cadet, content aware detection. You can talk about different types of capabilities like we're going to show here. So how do we detect the true file type using file magic calculation, and our ability to open password protected files in archives, of course. So the first thing we're going to do is we're going to go over the policy. It's not something that you need to do during the demo, but it is recommended that you'll go through the policy to understand it at least once or twice before you're running the demo. I also recommend, before you start the demo, launch the Smart Console. Okay, all you need to do is just click launch, and the Smart Console will be launched. it is being controlled from the domain controller. The domain controller is a machine behind the gateway that will allow us to control everything. So you'll see various various logs from the environment. You will notice that the access control is an any except. The reason why we're keeping it any except is because we're not focusing on access. From our point, the traffic already passed the firewall and the application control, okay? Because threat prevention will run after firewall and application control have already inspected the traffic and allow it to go. So we're running after the access control, we're running in the threat prevention policy. Notice that the policy is composed out of 3 rules. The first rule is an automatic rule whenever you enable MTA. So an automatic rule will be enabled. Notice that we're using the SandBlast profile in the action. Rule number 2, for any traffic, we got SandBlast profile with threat emulation, threat extraction enabled, and the antibot for the antibot network scenario. And the third rule has IPS. Okay, IPS and antibot if you want to move it and perform the basic threat prevention together. But in this case, when you do want to perform the IPS scenario, you will see that you'll need to move the IPS rule above the second rule, above the SandBlast rule, not the automatic rule. In the logs and monitoring, I would go and click the automatic refresh just so I can see the new logs. And now what we're going to do, we're going to start the scenario. The scenario is going to start from the mail vector, okay? So if you're going to go through the mail vector, if you're going to talk about, we're going to talk about the mail vector as the first vector. The 2 main vectors are the web and the email. We're going to start from the email vector. Before we can start, you can also go to the through the policy. The policy is configured according to the best practices. So the first stage will be like this. We're going to go to the attacker machine. We're going to open the email client here on the bottom. We're going to use the first email, stage 1, password protected archive file. Double click it, open it. And what we're going to do is we're going to attach the same resume.doc that we created a variant for, uploaded to VirusTotal, and it didn't detect anything. So I'm going to click open. This is an email that we've already created. And then I'll click send. From this point, I can go to the network protected machine. This machine is a user-based machine that's being protected by SandBlast network solution. And I'm gonna open the email client right here. So what you'll see, this email that you've already saw present here, the coupon, is part of the IPS scenario. So if you want to use it, you should read the IPS part. It's located in the last part of the guide. What we're going to focus is on the password protected file. What happened? From a user perspective, a user opened this attachment and noticed that the attachment was replaced with a text attachment saying that the original attachment, resume.doc, was removed by checkpoint. The reason, of course, it is malicious. How were we able to detect it was malicious? So resume.doc is not a document, it's an archive. We were able to detect, and you can show it from the domain controller. You go to the logs, look for the malicious archive log. You see the SMTP emulation here. Double click it, and what you can see here is the actual log for the emulation. Notice that at some point the summary report will appear. Sometimes it appears instantly. Sometimes it takes a minute or 2 for the summary report to appear in the log. So if you don't see it right now, what you need to do, click refresh. It will reload the logs and go to the SMTP emulation log. Now you see that it indexed it better. Double click it and now you can see the summary report. So we can go over the log. The first thing you should notice is that the file name is resume.doc, but the file type is zip. So it is an archive. We were able to detect that this was an archive. And once we've detected it's an archive, we tried to extract it. We noticed it was a password protected archive. We have a capability in threat emulation to open password protected archive with a built-in dictionary that's being updated from ThreatCloud with the most common used password and different campaign password out there. There's also, of course, a possibility for an administrator to add their own organizational password or different password that they feel like adding to the capability of threat emulation. The idea behind it is to also show and demonstrate that even if you're working with a fail open or fail close mode, there are situations where we'll be able to inspect different types of files, including password protected archives. In this case, if you're working in fail close, we will not block this. We will allow the user to receive that archive if it's not malicious. In this case, the archive is malicious and we've blocked it. What you should also show, click the summary report, you will see the new threat emulation reports from here. So the first report that you'll see is you'll see the attack vector. It's an email, it's very easy to understand. The verdict, the action that we performed, defined in the profile, the confidence, and additional details. You can also download the file from here. You can contact incident response. You can see the attacker, you can see the user, and you see all the files. So in an archive, you are able to see all the files inside that archive and their verdict. In this case, we have only one file, a document, that's called resume.doc. If I'll click it, now we'll see the emulation report for the actual document inside the password protected archive, which is also called resume.doc. Here you can see suspicious activities per machine, so per emulation machine. And one of the cool things about the report is that you can show an actual emulation video. So if I click here on the Windows 7, this is what happens during emulation. So this, you can see what happens during emulation. In this case, you can see that the resume.doc is an actual crypto locker, which, if opened on an unprotected machine, will encrypt the entire machine and the user will lose all their data. Additional fields in the report, you can see the trends, so the activity that happened on a machine, and of course a list of activities with the time that happened and what exactly happened. So what you can see here is everything that's happening on the machine. Okay, now what we're gonna do, so everything is documented in the guide. Everything I'm explaining, everything I'm showing is documented here on the guide. And now we're gonna move to a stage 2. So we've demonstrated threat emulation capabilities, and now we're gonna continue and we're gonna demonstrate threat extraction capabilities and the concept we call practical prevention. Practical prevention is our first line of defense, and practical prevention gives us the ability to have prevention that's also practical. That means that if I deploy a sandbox solution and I hold the files, I don't let the user receive the files in the first place, what happens is that the user will need to wait minute, 2 minutes, 5 minutes, 10 minutes, can be more. Usually with checkpoint, we see about 2 minutes on average. Other solution indicates on their data sheets that it's 5, 10, and even 15 minutes. So even 2 minutes when you're downloading files, it's not acceptable. This is why we have threat extraction. So beside having a practical prevention focused on accuracy and efficiency, which is the two core elements that we're showing with threat emulation, threat extraction will allow a user to receive a safe copy of a document, a PDF or an image, in a matter of seconds, while the original file is being sent to emulation. Okay? Now, there's additional capability with threat extraction is that users are able to receive the original files if they are not malicious. So if threat emulation said that this file is not malicious, the users can receive the original files by themselves. It means that there is no extra overhead to IT. So you can see the discussion points about the threat extraction solution. You can see the ability to receive sanitized and safe files to user, supporting the business continuity. The different advantages that we have with the threat extraction, allowing users to view the content. Even if the file is malicious by threat emulation, the user still has the content of the file. So I can decide as a user if I want to open a ticket and get the original file, if I need it, because if this file is not relevant for me, then I already know it and I will not open a ticket. So let's see how it works. These are the instructions. You can follow the instructions. And what we're going to do is we're going to go back to the attacker, the unprotected machine. We're going to open stage 2 threat extraction. And now we're going to attach the threat extraction demo.doc. Okay, notice, not the resume.doc, the threat extraction demo.doc. I'm going to click open and click send. In the meantime, let's open threat extraction demo from the malicious files here, shortcut on the desktop. Let's open the threat extraction demo.doc. What you should notice is this is a malicious file. It's just a sample to demonstrate a crypto locker attack. It doesn't do anything beside this demonstration. It's not encrypting the attacker machine, so it will allow us to continue the demonstration, but it is showing that if a user, an unprotected user, will open this document, they'll get encrypted. So if you want to close the document, you need to click here, you click end, and you click escape. So what we're going to do, we're going to go back to the network protected machine, click on send receive, and you'll see the second email. In this case, we've used the method of converting to PDF. Okay? One of the methods of threat extraction is convert to PDF. That means that every file format will be converted to PDF. I'm going to double click it, I'm going to open it, and notice this is opens in a PDF viewer and there's no pop-up. Okay, so the user is protected, the user is safe to browse this document and understand if this document, if this resume is relevant for them or not. And the additional thing is that in threat extraction, we have also the ability of keeping the same file format, removing all the active content and reconstructing it so a user that expects to receive, for instance, an Excel file will still receive an Excel file but without the active content. Our policy is set to extract with documents set to convert to PDF. So .doc.docx are set to convert to PDF in the policy. Other file types are set to extract. Extraction, basically cleaning the file, gives us a better user experience. The conversion to PDF gives us an added value of changing the viewer. Okay, so if it was supposed to open in an Office program, and now it's open as a PDF viewer, even if there's an exploit at some way, at some point, the exploit won't work because it's a different viewer. If you want to demonstrate receiving the original file, you can see that the link here in the email, you click here, you'll be forwarded to user check. You need to confirm. This is basically the user experience. So this is how users experiences the SandBlast protection. Justification is optional, but it will be mentioned in the log. So it is nice to have. What you can see here is that since threat emulation detected threat extraction demo.doc as a malicious file, the file is being prevented from the user. So the user has the safe copy. The user can work with it. In more than 95% of the cases, users don't request the original file. In this case, you can see that the user doesn't really need the original file because it's a resume. If you do want to show how a user can receive the original file, you go back to the attacker machine, you go to your sent items, right click, reply to all, and you can attach from the picture, you can attach the penguins. Okay, use the penguins, click open and click send. So now we've sent an email with a safe attachment. It's basically a picture, it's an image. What we want to show is we can show clean because images, as I mentioned before, are set to clean, not to convert to PDF. So you can see I received the same image. If you'll see the file name, you'll see we have appended .cleaned into it. .cleaned means threat extraction cleaned elements, active elements from the image. If I'll double click it, you'll see it is being opened as a JPG on the photo viewer. Same picture, you and I will not be able to notice, but it was being changed in the background, so no active content is running. I'm gonna click here, the link to receive the original file. I'm gonna confirm, write justification, and click confirm. Now you can see that I can download the file from here, And I've also have the ability to send the original email with the original attachment to me. Okay, so do SandBlast at unknown 300, that's our domain, and we're gonna click send. Let's see that SandBlast at, okay, my typo. And click send. You can see that mail was sent successfully. And then we can go to our inbox. This is the original email with the original attachment. Notice that this attachment doesn't have .clean append into it. Okay, you can open it, you can show it. It's the same attachment as the one we've sent from the attacker machine. From there on, you can see everything that happens through the guide. The second scenario demonstrating the impact we've shown before on the attacker machine. This is the scenario that we've opened the threat extraction demo.doc on the attacker machine. We can discuss detection versus prevention at that point. So if a user, for instance, receives a file while the file is sent in the background for emulation, the user still gets infected, the file still gets encrypted. Cost of remediating events versus the much lower cost of preventing them. So in this case, the malware will move laterally throughout the organization, encrypting user data instead of just being prevented from ever encrypting any user on a network. And of course, about infection time. Infection times, as I said before, sometimes it takes 5, 10, 15 minutes with other vendors to perform the emulation. So they say, okay, you put it in the background, and after some time, I'll tell you if it's malicious or not. What you can see here is that in this case, probably the users after 2-3 minutes will say, I've got encrypted, I can't work anymore, but the security solution didn't give me any indication about it. Maybe 10 or 15 minutes later, it will. So this is why we're discussing about prevention. We're focusing on prevention, on accuracy, efficiency, having threat emulation and threat extraction running together to allow business continuity and not to get users infected. Now what you can see also here is that you can demonstrate image extraction in self-catered. This is what we've done with the penguin image, talking about the practical prevention and so on. Stage 3 is another stage of demonstrating another threat emulation capability. Because sometimes, if I go back to the attacker machine and go to the SandBlast folder here, sometimes files are not attached to an email, but we have a link directly to a file in the email itself. So if you can see, click the link here. This is a link to an actual ransomware. This is a WannaCry ransomware. And the email doesn't have any attachment, but we do have a link directly to a file, and we're gonna click send. Go back to the network protected machine, click send receive. In this case, in this scenario, you will not receive the email. So the email is blocked. The reason is that threat emulation detects that link, and threat emulation, the engine, will download the file that is linked to the email, emulate it, and if the file is malicious, the email will be prevented. The entire email will be prevented. If the file itself is not malicious, then the email will be forwarded to the user. So in cases of links inside emails, all links are being inspected through reputation, and files are being downloaded through threat emulation to the gateway itself, sent to emulation, and the email will be forwarded to the user according to the verdict, and of course the action, because if you set the action to detect, then the email will still be forwarded to the user with a detection log. So what you can do is you can show all the information here. If you see here the protection name, malicious link from email, you can open it and you can see the detection. So what you can see is that the file name is the entire URL. This is the URL that was linked in the email. The file is an actual WannaCry sample. And of course, if you'll wait a minute or two, you'll also see the summary report for that sample. Same thing as we've done with the exploited doc document, the threat extraction demo.doc. So up until now, we discussed about the email vector, and you can see all the explanation in the guide here. Now we're going to discuss the web vector. In Checkpoint, we are able to protect email and web from a single architecture, from a single gateway. This is the story about Infinity, guys. And the goal here is to show practical prevention on a web vector, which is more critical, because in an email, if I say 1 minute, 2 minutes, okay, might be considerable as a reasonable delay for the added security, which I'm not sure that it's needed, but it may be reasonable. But for the web, users will not wait a minute or 2 minutes every time they download files. It's not acceptable, and there's no organization that will actually implement it. So this is why we're talking about practical prevention. From one hand, threat emulation with high level of efficiency and accuracy, enabling users to work. On the other hand, we have threat extraction, allowing users to receive safe copy of files in a matter of a few seconds while the original files are being emulated, with the additional capability of allowing users to receive the original files by themselves if they are not malicious by threat emulation. So you can see all the discussion points that we talk about, the instructions. This is a web extraction. Web extraction is with a hotfix on top of R80.10, and it will be part of R80.20 GA. So something to look forward to. What you should know that what we're doing here is every HTTP traffic is going through CPaaS. CPaaS is the same technology, the same way that we're doing HTTPS inspection. So it allows us to handle the connection and replace the file with a safe copy without breaking the connection or creating timeouts. So what you'll be able to see here is the following demonstration. From the network protected machine, open the Chrome browser. Let's open a new Chrome browser. You'll see a bookmark link here, John Smith Dropbox. Click it, and now you see a combination of files in John Smith Dropbox. The first file is a malicious file. So you click the John Smith Advanced CV. What you'll see is, since we've already know that this file is malicious, you'll not get extraction. What you'll see is that this file will get blocked. It takes a few seconds, and this is a cloud environment. You'll see that the file gets blocked, page blocked. This is what you see here. This file, John Smith CV, is the same file as a threat extraction demo.doc. Okay, it's the same file. We've already know that this file is malicious, so we're able to block it immediately. The two other samples, the financial report and the white paper, are benign files. The Excel one to demonstrate extraction with remove and clean and keeping the same file format. And of course, the document one will be converted to PDF as per the policy we've set. So once I click the John Smith financial report, you'll see it's being downloaded. If you open it, you see that it's .clean.xls. It means that this is the safe copy. First thing you should know is that we have here a watermark with the get original. The get original is the link to get the original file. The view chart is a macro. Click it, you'll see the macro is not running because it was removed. You can see the link here. There is no link to site here. The link was removed. You can see additional details. So we're keeping all the tables, we're keeping the pictures, we're keeping everything. We're removing all the active content and reconstructing the file using only safe elements. If I'm gonna click get original, what you'll be able to see is the same user check, confirmation, and click confirm. You can see sometimes you'll see the file being emulated, so you wait up to 1 minute usually for benign files, and you can click and download the original report. If I open the original report, notice it's exactly the same report here, but if I click view chart, macro will run and will create for me a graph with the entire financial report of John Smith. Same action can be performed with the document. So go to John Smith Dropbox, go to the document. Notice that we're doing convert to PDF. In this case, the file will be converted to PDF and will be opened in the browser, as browsers can show PDF files. So what you can see here is that John Smith white paper was open. You can go through that PDF now, show that it's a PDF. You can try to download. You'll see it's saved as a PDF. See, you can show that we're keeping all the tables, all the graphs, everything is being kept. All the content stays the same, but there is no active content. If I'll click Get Original here, you'll see the same user check and the ability to receive the actual docx. Open the docx, you'll see it's open in Word. It's the same file, same content. Okay, let's close this. And you can view everything I talked about in here. At the end of the SandBlast network, there's a summary pitch of everything that we talked about, from holistic end-to-end protection for zero-day attacks, leveraging evasion, leveraging CPU level to detect evasion techniques on OS level sandbox, threat emulation and threat extraction working together, the ability to prevent in the first time, okay, and not just on the background, but the first time we see an unknown file, if it is malicious, we'll be able to prevent it and to allow organization to be protected from zero-day attacks. There is another part to the network demo, and this part revolves around antibot. From the antibot scenario and the web extraction scenario that we just saw will be also shown on the agent. The idea is to show the protection on the network side and the added value when you're doing it on the agent with the SandBlast agent protection. And I'm going to talk about this once we'll get to the SandBlast agent. In the network, the antibot scenario, the goal here is to talk about post-infection. The reason is that there is no 100% prevention. Okay? At some point, at some way, there will be an infection. A small one, a big one. It depends on the security policy. But in this case, what we want to show is that in this scenario, and I'm going to start a scenario, the attacker was able to gain access to a machine on the internal network and using an instant messaging program of the organization to spread their malware. Okay, so everything is written here. You can follow the scenario, and I'll show it to you right now. So what we're gonna do, we're gonna go to the domain controller. On the domain controller, we're gonna use the Tonic instant messaging program. So if you see Vic here, so DOM and Vic, DOM is the domain controller, Vic is our network protected machine or our victim in this case. If you see it is grayed out, all you need to do is right click on the Tonic, it's the green button here. Click manage connection and click save. The same thing, you go to the network protected, right click on the green button, manage connection and click save. What it will do, you'll see that Vic becomes visible, and now you can start sending messages to them. So in this scenario, the attacker was able to connect to this domain controller, and before we're going to send our malware, we're going to execute the same code that we have here to create a variant. So what we're going to do now is we're going to create variant of bot exe. Bot exe is our bot that we're going to use. We're going to give him some random seed, and we've created a new hash of that file. Now we're going to send it to Vic. Okay, you can tell the story about Dom and Vic if you want to. Dom and Vic are very good friends. They usually drink coffee together, they eat their lunch together, and one of the things they like the most is they're sharing various program between one another because they like it, and they like to share and show that everybody can, every one of them can find some cool and neat program that they can use during their work or just for fun. So in this case, I'm gonna right click on Vic, click on file. I'm gonna choose from the desktop malicious files, gonna choose the bot exe. And I'm gonna write something like check this out and gonna click send. Going to the network protected machine, I see, okay, I have a message from Dom. Let's click on the message. Now, usually they accept without ever thinking, and let's run it. You'll see a PowerShell that goes up and goes down. And from the network, from the user point, in this case, this is all you're gonna see, okay? This is just a network protected machine. There is no endpoint protection. In most cases, you won't even see the PowerShell. We're just showing the PowerShell so you'll know that something is running. But what you can see is that something is running on the machine. Nothing happens, might be faulted. The user doesn't really know what to think, and that's it. If you want to really see what's going on, you go to the domain controller, to the logs, and make sure that you refresh or click automatic. And what you'll see here is you'll see a block log from Antibot. This is the detection. This is the bot detection. You can see that Antibot was able to block the communication. The communication was a communication to a command and control. And in this communication, if I click more, you can see the command and control URL. You can see the protection name. Of course, this is our domain. It's something that we're using for demonstrations. And what you can see here is that the security solution was able to detect and prevent the access to the command and control, and in this case, the exfiltration of data. The problem is that the malware and the shellcode are still working because there is no endpoint protection. So from the user perspective here, the malware is still running on their system. With the SandBlast agent, we're going to run the same scenario on a SandBlast agent protected machine, and you'll be able to see the remediation, quarantine of the malicious and the bot, and of course the entire forensics report on the endpoint. And this is how you can demonstrate and show the added value of deploying SandBlast agent with our network protection. We don't want only endpoint protection because endpoint is the last line of defense. If I get infected on the endpoint, it's very bad. Okay, something will get damaged. If I can stop on the network, I'll stop everything I can on the network, and this way it will not enter my organization or my entire user and servers and so on. So the scenario that I've described is written here with, of course, what to show with the SandBlast agent. If you don't intend to run, or if you don't want to run the SandBlast agent scenarios, you can show the forensics report. So on the network protected machine, you have here SBA-AB report. Just open it. This is basically the forensics report that you will see when you run the SandBlast agent antibot scenario. So you can explain the endpoint protection from this forensics report. We're going to discuss this shortly with the SandBlast agent scenarios.